again, everyone. Bob Martin, the RCSubGuy with the NautilusDryDocks.com. Thanks for joining me again. We're going to continue this saga building 196 scale U.S. Ohio Class ballistic missile submarine. We have got two other chapters that you may have seen up to this point. So if you want to see how we got here, you're going to need to check out those two other videos. For this one, though, we are going to continue on with setting up the drive system of the boat. So basically the propeller shaft, the propeller, and the control surfaces of the boat. So the rear dive planes, the rear rudders, and the forward dive planes, which are mounted on the sail. So I've got a little bit of work that took place between the last video and this one. I'm going to catch you up to where we're at right now, and we're going to continue rolling along and see if we can get this thing in the water. All right, the first thing that you are going to notice is that I have a cylinder in there. The second thing, if you're really observant, is that the cylinder is cracked, damaged, and otherwise inoperable. So this damage occurred in shipping from the United Kingdom. Despite Bob Dimmack's best efforts, the delivery people smashed the acrylic ballast tank, which basically means the entire center section is a write-off. So I've got a new one coming, should be here in a little bit, but I've got it put together just to mock up the size. As I mentioned before, this is a 30-inch overall cylinder, a 3.5-inch diameter dive module unit. Sits nicely inside the supplied cradles that come from SubmarineWorks. I had to do a little bit of grinding just to get perfect alignment in there so that it sat down nice and low, but there was certainly not a lot of work in there. As I mentioned earlier, I set these bulkheads back about an inch, inch and a half from the edge, and the reason is I've created these bulkheads which are going to be holding the cylinder down. I've got one kind of sitting in place waiting to be adhered in the back, and you can see that the lugs that hold the end caps on, they just basically slip into place. And the idea behind this is that you drop it down, slide it back, locks into place, and then you bolt it from the front. So pretty slick system. I've used it on other boats before. The other thing that you're going to notice is that we now have a drive shaft in place. Now this was a very straightforward installation, and that's why I didn't go into too much detail. I basically elected not to utilize the supplied end piece with the integrated bearing from SubmarineWorks. And if we back up here and show you what that looks like, I mean, it's certainly very nice. Got an integrated brass bushing on the inside. But what that would actually require you to do is cut the back off, grind it, fit it, sand it, make it flush. I don't think there was any need for that. The back made it up really, really well. Filed it flat. I cut in a hole, a 1/4 inch diameter hole for a bushing, an oil light bushing. And the big thing about this, when you install it, make sure that you've got your cylinder in place. And what that'll allow you to do is install the drive shaft and get it oriented perfectly in line with the output shaft of your cylinder before you adhere this secondary guide bushing. So basically put the shaft in place on the this little dog bone connector, slip this in place, and then adhere it. What that allows you to do is maintain perfect alignment between this dog bone and the adapter, so that the cylinder basically just, whoop, I just pulled it right out, basically just slips in place. Since we're on this, you can see I've got a, let me see if I can get this back in place in the rear here. All right, important things to note of the drive shaft here. This is a 3/16 inch stainless steel drive shaft running on an oil light bushing front and rear. What will end up happening is this forward retaining collar, this is just a wheel collar, will stop the shaft from slipping backwards, and the propeller itself will stop it from slipping forward, thereby pinning the entire drive shaft in place. spins very, very easily. I haven't lubricated it at all, and once I do, it will be exceptionally smooth and free rotating, which is exactly what you want with zero vibration. That's the important part. So this is basically all set to go. What we're going to need to do is clean up these mating surfaces for all of the rear control surfaces, get that ready to put our rear dive planes on. Last thing I wanted to touch on, I told you before I was going to do it, just put a little bit of tape over the openings of these navigation lights and backfilled it with resin, clear resin. Peel the tape off and you've got clear lenses over each of the navigation lights in the side of the tower. So during painting we'll just mask those off, and once it is all painted, peel them and we will have clear lenses ready to go. All right, let's move on to installation of the rear control surfaces. I've got the two side keels here, really nice. I haven't cleaned these up yet. Make sure that you do. And as a general note, make sure that you are washing these parts prior to installation to remove all of the mold release that might be clinging to the outside surfaces. As you can see, you've actually got a raised portion on this rear hull that is going to show you the correct place to mount this, so the profiles will match up. And you do have some orientation tabs that stick out on the bottom here. So the next step is to ensure that we have proper alignment. Mark out the holes, drill them, and I would recommend just a little bit of slop, a little bit of play, so that if you need to move it a 32nd of an inch to get perfect alignment up or down or back and forth, that you do have that wiggle room. So I'm going to do that on both sides. The other thing I'm going to do, I've already roughed this out with a file just to get this a little bit smoother. I'm going to put some glazing putty on that, sand it all down and make it look really nice. All right, as you can see, I have filled and sanded the rear of the hull there, got everything all nice and smooth. I've done the same for the rear control surfaces. I've got those all filled, sanded and smooth. Now we're going to go about drilling holes for the actual control surfaces. So these are the dive planes. They come pre-mounted with these rectangular shafts. Looks like those are actually cast directly in place, which is great. Set that in place on the rear stabilizer there, and you're going to want to add about 1 millimeter of clearance in between. From there, what I did, I just got this spacing tool, and I'm going to mark it, take a reference off the front of the stabilizer there, and then I'm going to reference that to the center of the dive plane, and that will allow me to gauge the distance that I need to go back from the front in order to drill my hole. So we're going to do that on both sides. All right, as you can probably see, I've got the port side stabilizer and dive plane installed. Nice and free moving, no binding, everything is centralized. Now I suppose you are wondering how I did it. So what I ended up doing, as I showed you earlier on, is marking out the holes, and I installed a 5/32 inch diameter piece of brass tubing, and that just happens to fit over this square tubing fairly well, so that just slips in like that. The other thing that I did is I ran this piece of 1/8 inch brass tubing through, thinking that I was a very clever individual, because then I would ensure that I would get perfect alignment between the two dive planes. But unfortunately, the dive planes are not parallel to each other. They're actually canted back at a tiny bit of an angle, which meant I had to do a little bit of rework in the back there, and you can actually see a bit of my boo-boo right here. in that I had a hole drilled. Now, that is not the end of the world, and a little tip for you, if you ever do make a hole or a gouge that you need filled, use a little bit of baking soda and some thin CA glue, and that'll form itself up just like concrete, and you can drill and tap that if you like. So obviously we need to change our methodology, and first thing that I went about doing is measuring the distance from the leading edge of the dive plane to the center of the shaft, and then marking it out on the back here. And what that allows us to do is get a perfect alignment of this drive shaft moving up the center of the dive plane. I'm going to mark that out and drill it for a 1/8 inch shaft. So I just had a thought, and it came to me as I was looking at this dive plane casting, of course the second dive plane casting after that first one that I was looking at. You can see there's a nub on the end of it, and of course what that probably means is that nub is in alignment with the shaft, and that would allow you to create a parallel shaft that would run through the inside. You get all of your alignment all set up, and that would be completely wonderful, and you can do that. So if you don't like what I am doing here, you can go about aligning everything, and the way that I went about that is I told you I sent this shaft right through the middle of both of these 5/32 inch brass tubing bearings that I installed, and then that'll allow you to run that through, mark out your hole on the stabilizer, and it would be much easier. But the thing about that is, with that dive plane canted off to the side, as it rolls, it would change the spacing between the stabilizer and the dive plane. So I thought it would be best to maintain parallel line with that drive shaft and the stabilizer, just so it looks a little cleaner as it actuates. In practical application, only you will ever know and nobody else. This would do away with the possibility of some misalignment and rubbing though. So little side note, do it the easy way like I mentioned before, which I'm probably going to recommend to you, or do it the hard way, which I'm about to show you. Alright, you can see that I have installed a piece of 1/8 inch tubing to act as the extension for my shaft. It's perfectly in alignment with that shaft. Now what I am going to do is basically set the dive plane in place, and I'm going to draw it back, that same 1 millimeter that we spoke about before. Draw it back 1 millimeter. So it'll look something like this, and then I'm going to mark out where that shaft intersects the stabilizer, and then drill the 5/16 inch hole to accept a piece of brass tubing that will act as an outer bushing for that shaft. Alrighty, here is what we have ended up with. This is probably just less than 1/8 of an inch protruding from the bottom there, which I find to be the correct distance. You can see he sets that in, everything moves nicely. You can slip the drive shaft in, get that stabilizer in place, and we've got nice, easy movement of the plane up and down, no binding. The other thing that you might want to do at this point is just ensure that you twist that stabilizer in such a manner that the dive plane is centered on that stabilizer, so it looks nice cosmetically. Everything lines up and looks good. So adhering this to the model is going to be very important, because if it's ever going to break during transport, it's going to be at this point. I highly recommend roughing this up with your Dremel tool. Get a nice rough craggy surface on the inside, and do the same to the mating surface. Utilize some high strength epoxy. Make sure that you get a good bond between those parts. All right, the next logical step obviously is installation of the rudders. Hey, there's a rudder right there. I just drilled out a 1/8 hole there, which just fits the shaft. Now, the challenge with this that I'm running into is that the square tubing that comes embedded in these parts does not make a nice 1/8 inch diagonal, and so when you put it in a 1/8 inch oil light bearing, for example, you get some slop, you get some play. I don't like that. It's gonna rattle, it's gonna move, it'll be, you know, off center. That's kind of sucky. So what I have elected to do is a little bit of creative surgery. I'm gonna sleeve that shaft with that 5/16 inch brass tube. I'm going to show you how to do that nice and easily so that we'll have a nice round surface that we'll be able to put a bearing on that will have an incredibly stable shaft so that we don't get any wiggling. What I have here is a piece of the aforementioned brass tubing. And I chewed up the end of it with my rotary tool to make kind of a jagged little end on there. Now what I am going to do is slip that over that square tubing shaft, just like this, fire up the drill and basically press it in about 1/4 inch so it embeds itself into the resin. Just like that. And now I'm going to take that out, I'm going to glue it in place, and we'll have a beautiful shaft that we will be able to put a bearing on. All right, so I've got my little bushing right here. I have roughed up the edges so we'll get a nice bond. I'm going to slip that on the drive shaft to make sure that we got nice smooth operation with no binding. So obviously alignment is going to be very, very important. The holes for the rudders were marked out top and bottom. I've drilled those out to accept those bushings that I made. And I've also gotten a piece of brass tubing that fits inside, the same diameter as that shaft that I put on the overbore for the rudders. And there is a reason for that. We can slip this all the way through, and then we can put our lower bushing in place. Slip that into the hole, press it up. We can put the top one in place. Drop that down. And now we are ensured of a perfect alignment between the upper and lower rudder. We can adhere the bushings in place, top and bottom, and we should be in good shape to install our rudders. All right, we need to make some horns that are going to connect to our linkages to actuate our control surfaces. I have a video making your own control horns. Go find that if you want all the nitty-gritty details. I'm gonna do this real quick and fast forward, see if you can follow along. But again, the details are on that other video, fabricating our own control horns. So let's get some horn built. There we go, as easy as that. Got 4 done in about 5 minutes. Let's take a look at the back here. Now I have added a stiffening bulkhead on the inside of this upper section in the back there, just to make sure we get a nice clean seam on the back there without having to worry about anything flexing. And this is the linkages that I've got. So if we take a look on the inside there, as I mentioned, I don't like the U-shaped connectors that come with the kit. They're perfectly fine. If you're comfortable with that, by all means go ahead and use them. But things are tight in there, and when you start and get too much stuff, makes it tricky to work on. So these are just very simple horns that connect to each control surface, and then they come forward, and then this is where they connect together. So if we take a look at the stern planes, we've got adjustability in there. We can loosen off these collets, or the wheel collars, sorry, adjust the linkages, get everything perfectly aligned. And it's the same thing with the rudders, and everything is moving nice and smoothly. We've got a direct connection, going to go all the way up there, magnetic connections to the back of the cylinder. So those are our control surfaces, our linkages. What I have also done is worked out the front hold down, and I actually had to rework this because the way that the back is set up, the cylinder needs to drop in perfectly flat and then slide forward to engage that dog bone at the back. And so I needed to make this connection or this lockdown such that it slips in from the back, and so I just made some little slots, some little keys on the inside that gets pressed into place. I have completed the linkages to the best of my recollection here. Let's take a look at the front. So you saw how I put together the sail there earlier, and if we take a look at what we've got going on there, you see the little arm inside. Just a simple 1/16 of an inch brass rod and a wheel collar in there to lock it in place. A length of linkage there with a threaded rod, so we've got some adjustability in our magnetic linkage there. And if we take a look at the mating surface on the inside, we've got our cylinder, we've got the output for the servo, and then I've got this like L-shaped linkage here. And again, that's a magnetic connector on the other side. And the cool thing about that is it allows some flexibility, some bend with but still offering a very firm connection. So the idea is that this will move back and forth. We've obviously got some nice play in the sail connector right there, and it's just a really slick system. So once this is connected, this will maintain its position right here. You drop the sail down and the magnetic connector snaps together. So that's a very slick system. What I am going to work on now is the magnetic hold down for the missile deck. And for that I am going to be utilizing these 1/4 inch by 1/4 inch cylinder magnets. Got these from gossboys.com. What I'm going to do is I'm going to drill in holes into the hull and flush mount the magnets. And then I'm going to put the mating magnets on top after I lay down a bit of tape, so that when I adhere these upper magnets into the missile deck, they don't glue themselves to the lower one. So that's a lot to understand verbally. Let me show you how it's done practically. Alright, here are our magnets sitting in place there. They're sitting just proud of the hull. These are the mating magnets, and super strong, as you can see there. So what I want to do is I'm going to put this tape, masking tape, over top, and then I'm going to take each one of these magnets, and before I put them in, I just want you to notice I roughed up the outside cylinder just a little bit with my Dremel so that the adhesive bites onto it really well. There we go. So I'll lay down a couple more strips of masking tape. And then what I'm going to do, I'm going to put a whole bunch of adhesive of that auto body filler in over top. Press the missile deck down, let that set up, and it'll bite into that nice and solid. And in theory, I should just be able to lift it right off, and we'll have perfect alignment between the magnets with perfect spacing. All right, everyone, we are going to be wrapping up this chapter of the build. Let's review where we are at right now. So last step that I showed you was the magnetic hold down for the missile deck, and that turned out really, really well. This is actually a really firm connection. You can hear it snap into place. Those two magnets are exceptionally powerful. Obviously, if you're worried about it, you can add more too, but I think this is going to be more than adequate, and it'll allow you to gain easy access to the model simply by lifting up and putting the deck off, just like that. With these openings in the top, it also gives you good visibility to your cylinder inside, and with the big cutout in the front, access to the linkages. Removing the rear section, which is a simple single screw, also gives great access to all of the rear linkages as well. Rear linkages are completed at this point. They move very well, very freely. Drivetrain is in place. Cylinder mounts are in place. Again, reviewing how to get into the model. Again, magnetic clicking hold down in the back there with that hold down ring. Just slide everything forward, lift it off, and you've got full access to the installation and removal of our cylinder. So where I am at right now, basically the rear hold downs for the cylinder are in place. I'm going to wait on the front ones until I get that replacement ballast tank that has been shipped to me by Bob Dimek at OTW, expecting that anytime after that's done. Just to ensure that that length is proper, I will get that front bulkhead installed, and that will be ready to go. So we are getting really close on this. In the next chapter, we'll probably go into the installation of some ballast weight, some foam, and then we're going to start talking about some cosmetics. We're going to start throwing some paint on this. As always, thanks for joining me. This is Bob Martin, the RCSubGuy. Be sure to visit my website, nautilusdrydocks.com, for lots of information, resources, parts, kits, and components that you can get for this amazing hobby of RC submarines. Again, thanks for joining me. We'll catch you next time.